Hello students, so in this video we will solve exercise 6.2. So here is the first question that in this question DE is parallel to BC. Okay, so by B.P.T we can say that these sides are in proportion. Okay, so let me solve. So in this question we have to find the side EC. Okay, so for that we will write by B.P.T, by Basic Proportionality Theorem, and before that just write in triangle ABC DE is parallel to BC. Okay, then only we can apply B.P.T, means Basic Proportionality Theorem. So by this, what is the conclusion that we have? AD upon DB, which will be equals to AE upon EC. Okay, now we have AD as 1.5 and DB as 3, AE as 1 centimeter, and we have to find EC. So by simply cross multiplication we can solve and we will get our answer. So from here we have EC is equals to 3 upon 1.5, that is EC is equals to 2 centimeter. Okay, so in this way we have to solve. So here is the second question. In this question also what we have to do, we have to find AD. So AD upon DB is equals to AE upon EC, because in triangle ABC DE line is parallel to BC. Okay, now let's move to question number 2. In this question it is said that E and F are the points on the side PQ and QR respectively of a triangle PQR. So let us draw a triangle first. So here is the triangle PQR, in which P is the a point on line PQ and F is the point on line PR. Now we have three part in this question. So we just have to prove that what we have to show, EF is parallel to QR, means this line is parallel to this line. So when it is parallel, what we just have to prove is that PE upon EQ is equals to PF upon, look, PE upon EQ is equals to PF upon FR. If we get this in same proportion, then only we can say that EF is parallel to QR. So all you need to do is just putting all the values in this formula. Okay, now let's move to another question. So in this question, in figure 6.18 means this one, LM, this line LM is parallel to BC and LN is parallel to CD. What we have to prove is that AM upon MB is equals to AN upon ND, AN upon AD. Okay, so for that we need to draw this figure in our copy and let us solve. So this is our question. So first of all we will take in triangle ABC. Okay, we know that LM is parallel to BC. So we can say that AM upon MB is equals to AL upon LC. Okay, but we can also take that AM upon AB whole equals to AL upon LC. This we have already proved three results in our B.P.T when we are proving B.P.T theorem. In our previous video I have told there that we can take any ratios because all the proportion is equal whenever the triangle is similar or a parallel line is passing through, a line is parallel to any side of the triangle. Okay, so let me take here this one. Okay, at last we will change that. So from here we have our first equation. Now we will take in triangle ADC. So here LN is parallel to CD. Okay, this line is parallel to this line, means they are divided in same ratio. So we can say that AN upon ND is equals to AL upon LC. Second, so by these two equations we will get AM upon MB and AN upon ND. So from here what we will do, we will just reciprocal them. Okay, do the reciprocal. So from here we will have MB upon AM is equals to ND upon AN. Okay, so now we will add 1 to both sides. By Euclid methods we can add or subtract anything from both sides of equal sign. So from here if we take the LCM, in numerator we have MB plus AM upon AM is equals to ND plus AN upon AN. Okay, so look at the figure here. AMB plus AM, okay, it is equals to AB. So from here we have AB upon AM is equals to, and this will be AD upon AN. Okay, again we will reciprocal them, so we have AM upon AB equals to AN upon AD, and this is what we have to prove. Okay, so in this way you can solve. Look, geometry is not that much difficult. All you just need to do is to learn the concept. Okay, once if you get the constant, you can answer any question by several methods. Okay, there are not a fixed method in geometry that you just have to apply this method to get the answer. You can apply as many methods as you can. All you just need to do is understand the concept. Okay, so I hope by these questions you will understand the concept. So let's move to further question, which is question number 4. So in this question, look here, DE, this DE is parallel to AC. So we can say that AD upon DB is equals to BE upon EC. Okay, now we will take, look, for triangle ABE, for triangle ABE, DF is parallel to AE. So we can say that AD upon DB is equals to BF upon FE. Okay, or BE upon EC. Okay, so from here we can say that AD upon DB is equals to BF upon FE, and also for triangle ABC, AD upon DB is equals to BE upon EC. Okay, so both these sides are equals to AD upon DB, so we can say that BE upon EC is equals to BF upon FE. Okay, so I hope you can solve this by your own. Let's move to next question, which is question number 5. In this question, it is said that DE is parallel to OQ. So this side DE, it is parallel to OQ. Okay, this is OQ. So we can say that PE upon EQ is equals to PD upon OD, DO or OD. Okay, PD upon OD. And DF, this line is parallel to OR. So we can say that PF upon FR is equals to PD upon DO. Okay, so both these sides are equals to PD upon DO. So by that we can say that PE upon EQ is equals to PF upon FR. Okay, so for triangle PQR, if PE upon EQ is equals to PF upon PER, FR means they are in same proportion. So we can say that EF is parallel to QR. Okay. Yes, now question number 6. In this question, A, B, C are the points on OP, OQ and OR respectively. Okay, so look here, what is said. You just need to listen it carefully. Just look, first of all, what is the triangle? We have a triangle OPQ or POQ, this triangle. Okay, this is the triangle. So in this triangle, AB is parallel to PQ. So we can say that OA upon AP is equals to OB upon BQ. Okay, we can say that. Now for triangle POR, for this triangle, so here also we can say that OA upon AP is equals to OC upon CR. Okay, so from this, both of that are equals to PA upon AP, OP or OA upon AP. Okay, so we can say that OB upon BQ is equals to OC upon CR. Okay, now for triangle QOR, if the sides are in proportion, we can say that BC is parallel to QR by converse of B.P.T. Okay, now let's move to question number 7. These are the questions recall from your previous class. In class 9th also you have learned about the midpoint theorem. So this is the proving of midpoint theorem by similarity, okay, or by basis proportionality theorem. So from there you have just proved it by congruency method, and here you can apply similarity also. Okay, so this shows that in geometry you can apply any method. All you just need to know is about concept. Okay, so let's do question number 7. So using theorem 6.1, we have to use theorem B.P.T. Okay, so what we have to prove that if a line is parallel to the third side, it bisect the third side. Okay, let me show. So by using theorem number 7.1 means by BPT we have to prove that we have a triangle. Look, this is our triangle. Okay, this is A, this is B, and this is C. So if a line, look, this is the line, it is bisecting here, and this line is parallel to BC. Name this line as E or F. So what we have to prove that it is bisecting the third side. Bisecting the third side means AF upon FC. Okay, this will be equals to AE upon BC. Okay, if we show that means if it is bisecting side AB in 1:2, then it is also bisecting the AC line in 1:2. Okay, so we have EF is parallel to BC in triangle ABC. Okay, so simply by BPT we can say that ki AE upon EB is equals to AF upon FC. Okay, so if it is in 1:2, then this will automatically will become in proportion 1/2, in ratio 1/2. Okay, so by this we can say that a line parallel to the one side of a triangle, it bisect the third side. Okay, it is also, look, it is also bisecting, because if these two lines are parallel, they are in same proportion. Okay, this is we have got about for got by BPT, Basic Proportionality Theorem. Okay, so its converse is also true. Its converse is also true, which is your next question, that if line joining the midpoints of any two sides of a triangle is parallel to the third side. Okay. So here we can say that, look, this is our triangle. Okay, if this is the midpoint of side AB and this is the midpoint of side AC, so name this as E and F. If we join this line, what we have, that EF is parallel to BC. So look, if AE is the midpoint, we can say that AE is equals to EB, and if F is the midpoint, we can say that AF is equals to FC. Okay, so now what we just need to prove, that EF upon BC. So if we take them in proportion, that AE upon EB is equals to AF upon FC. Okay, so if this is the midpoint of side AB, so we can say that AE upon EB, it is also, the two will cancel out. Okay, and here also these two are equal, so these two will cancel out. 1 is equals to 1 means they are in same proportion. So we can say that EF is parallel to BC. Okay, EF is parallel to BC. Now let's move to question number 9. So in this question, ABCD is a trapezium, it is given, means AB is parallel to CD. Okay, and its diagonal intersect each other at point O. What we need to show is that AO upon BO is equals to CO upon DO. Okay, so let us solve in our copy. Yes, so this is our question number 9. In this question, this is the trapezium. It means that AB is parallel to CD, or it is already given. So we need to prove this. Okay, when its diagonal are by intersecting at O. So what we just need to do here is we need a construction. So what is the construction? We will draw a line EF which is parallel to CD. Okay, so it will automatically will become parallel to AB because these two are in parallel. So let us draw EF here. This is E, this is F. Okay, so first of all, if this line is parallel to CD, then its part will also be parallel to CD. Okay, EO will parallel to CD. Okay, so now in triangle ADC, okay, in this triangle, look, EO is parallel to CD. Look at the triangle, you need a unique view here. Okay, this is our triangle. About what we are talking. So this is the line which is parallel to one side. Okay, so we can say that AE upon ED, let me write AE upon ED is equals to AO upon OC, AO upon OC. Okay, so let this our first equation. Now in triangle, look at this triangle ABD, triangle ABD. Okay, this is our triangle. So in this triangle also, look, EO is parallel to AB, EO is parallel to AB. Okay, because if it is parallel to CD and AB is parallel to CD, so EO is automatically parallel to AB. These are the postulates of the Euclid that you have learned in your previous class. No need to prove here. Okay, so in this triangle, if this is so from here also we can say that AE upon ED is equals to OB upon OD. Okay, or OD upon OB. So from here we have AE upon ED is equals to BO upon OD. Okay, this is our second equation. Look, this is also equals to AE upon ED, this is also equals to AE upon AD. So from here we can say that AO upon OC is equals to BO upon OD. Now what we just need to do is cross multiplication here. So this will become AO upon this OB will go downwards. So BO is equals to OC upon OD or DO. And this is what we have to prove. Okay, so question number 10, it is also same as this one. So in that question what we just need to do is look, it is already given in question that AO upon BO is equals to CO upon DO. Okay, so what you just need to do here is first cross multiply them. So AO upon CO is equals to BO upon DO. Okay, so by that you can show that that AB is parallel to CD. Okay, AB is parallel to CD, and if AB is parallel to CD, ABCD is a trapezium. Okay, this you can solve by your own. So I hope you understand all the concepts of BPT, where we can use, how we can use BPT and its converse. Okay, but so it is very important theorem which can be asked directly in your board examination about 4 marks, about 4 marks. Okay, and they can directly give you that just solve or just prove the BPT theorem, or just prove the converse of the basic proportionality theorem. It is also known by Thales theorem. So keep in your mind, if you have any doubt, let me know. Okay, thank you.